All right, so what I did is I wrote my identities over here to the right that I'm wanting to use because I have a cotangent squared and a tangent squared. So cotangent squared is actually solving for this piece right here. So I'm just going to subtract 1 to both sides. So that gives me cotangent is cosecant squared x minus 1. And then tangent squared x. Tangent squared x means I'm going to pull this 1 over to the other side, but be careful, it's minus tangent squared x, which gives me secant squared x minus 1. I had to double check. Okay, now what I'm going to do is I'm going to make this minus right here distribute through. So it's plus a negative, and that minus becomes a plus. So I've just distributed my minus sign. All right, so once I've distributed the minus sign, that leaves me cosecant squared x minus 1 minus secant squared x plus 1. Guess what happens with the plus 1 and the minus 1? They cancel if you didn't figure that out. So cosecant squared x minus secant, notice I left out my x, secant squared x is what I am trying to get. Yay, me. Okay, there we go. There's the next one. Okay, so looking at this one, oh, I am on a full screen. Oh, well, it doesn't matter. Okay, so on this one, I'm going to be using the same kind of thing. Now, I'm going to change out, I'm trying to get to sign, like looking at where I'm going, trying to get to. This is what I'm trying to prove. I'm trying to get to that. So it's important that I pay attention to that. So what I'm going to do is I'm going to take the cosine and I'm going to use sine squared x plus cosine squared x equals 1. And I'm solving for cosine. So that means it's going to move sine over here to this side as minus sine squared x. Just saying. That's what I would have to move. All right. So that means I have 1 minus, changing out cosine. Okay, I'm going to color code this so you can see it. So I'm going to underline this in red. What's cosine is going to be 1 minus sine squared x. And then back to the black again. Sorry. And then 1 plus, and I'm going to change out, put in with red again. What was cosine is 1 minus sine squared theta. Okay, now 1 minus this means, oh, I have to distribute this. So this becomes minus, minus, plus. I have nothing to distribute here. So now all I have to do is simplify. So getting rid of the parentheses, ooh, I have a times here. Hold the phone. All I did was replace that. This is all multiplied. I kind of left that out. This is being multiplied right here. Can't leave that out. So what I have here is 1 minus 1, which is 0. These cancel, okay? And this leaves me sine squared x times, then what cancels over here is these don't cancel. They actually add up. You end up with 2 minus sine squared x. So now I'm going to distribute, and I'm left with 2 sine squared x minus sine to the 4th x. Oh my gosh, I got exactly that. I am oh so happy. And here, I'll draw you some cute little teeth in here. Yay! He's happy. He's a big toothy grin. Okay. Sorry, expecting a grandbaby. I'm just like, yeah. Okay. So this one, I think I like the idea of getting rid of secants and cosecants and turning them into sines and cosines. Left side is definitely more complicated, so that's the one I'm going to change. Secant becomes 1 over cosine squared x. Cosecant becomes 1 over sine squared x. So everything else I'm going to keep the same. Sine squared x plus sine squared x times. Okay, now when you look at this, what's really cool is that you're going to notice these two cancel. Hot dog, if you want to put it over 1 to make you happy, you can. If you want to put this over 1 and just multiply straight across, you end up with sine squared x over cosine squared x. And then this all went to 1 because it canceled. But it doesn't cancel to 0. Be careful. Sine squared x over cosine squared x is equal to tangent squared x plus 1. I'm double checking these as I go because somebody told me I made a mistake and wrote tangent instead of cotangent on one of the earlier problems. Okay, this actually goes back to our last page. Whoops, 2 pages ago. So we have tangent is equal to secant squared x minus 1. Tangent is equal to secant squared x minus 1 and then plus 1. So this piece alone for tangent squared x, is secant squared x minus 1. Okay, so now we're just going to do the plus 1 minus 1. They cancel, and I'm at secant squared x. Hot dog! We have it. Big smiley face. And somebody liked a fat tongue in 7th period. They thought it was funny, so there you go. Hee hee. We can even give them eyelashes. There you go. Next. All right, we're going to verify number 6. And on this one, this one's a little special. If you weren't here in class, you didn't have me to remind you of this, and I'm about to do so. So looking at the front and the back of this and noticing what my pieces are in the middle, this is a perfect square. It's cosine squared x times cosine squared x, and it gives you cosine to the 4th x. This would be sine squared x times sine squared x would give you sine to the 4th x. So what I had given them in class was this. If you have a plus or minus b squared, this is straight out of algebra, guys. It is a squared plus or minus 2ab plus, not minus, b squared. Okay? So this is the exact pattern that I have going on here. See the 2 right here, the 2 right there, and your A and your B is your sine squared and cosine squared. So I can see this as sine squared x plus cosine squared x squared. Okay, it is A plus B squared. It's this right here. All right, there's no minus sign, so this did not end up a minus sign. Well, guess what? Sine squared plus cosine squared, it's 1. And 1 squared is 1. And that's exactly what we had. Smiley face. Okay. Got it? Somebody said, where's his nose? Here, I'll give him a nose. All right. Number 7, verify. The one that looks more complicated is definitely the left. The way I did this one was 1 divided by, I have to divide it by all of tangent. With a plus sign, I cannot separate it. Plus cotangent x. And then I'm going to take these and turn them into sines and cosines. So sine x over cosine x plus cosine x over sine x. We can't add these, and we can't divide it yet. We can't flip this until we have a common denominator. So what I'm going to do is I'm going to take these and I'm going to say times sine over sine and cosine over cosine. Okay. And what that gives me, this 1 divided by, all of this is still here. And don't cancel these. Don't cancel because we just took the time to multiply them. I'm going to multiply these, and when I multiply the denominators, they come out to the same thing, sine x cosine x. And so the top gives me sine squared on the left side and cosine squared x on the second side. And now I have 1 divided by that. Now that I have a common denominator, I can flip this thing, but in the course of flipping this, I want you to notice what's right here. We have sine squared x plus cosine squared x. That goes to 1. So when I flip this, keep, change, flip, 1, change, flip. The 1's cancel. We don't need them. They're only multiplying, dividing by 1, so that doesn't change anything. And look, we are done. We have it. One more. Okay, so this one I have, let's see, definitely the left side is more complicated. Right away, I see that I need to have a common denominator because I can't add these or do anything to it. So sine x over sine x, sorry, the trash can is rolling down here. 1 plus cosine x over 1 plus cosine x. And this gives me sine squared x plus, okay, I'm going to distribute cosine all the way through here. So I get cosine, whoops, not a squared, my bad, cosine x plus cosine squared x. Okay, I want to point out what I did. This right here, distributing that, gave me this piece right here. Now, it's going to all be over. Now, I'm going to have sine x times 1 plus cosine x. You see what I did? Okay, now I'm going to swap these places because you're not in class with me, so I'm going to take the time to do that. So I'm going to have sine squared x plus cosine squared x plus cosine x. All I did was swap these two places, and that is okay to do. If you agree with me that 1 plus 2 is the same as 2 plus 1, this is okay to do. So now I have sine x times 1 plus cosine x. And then this right here is Pythagorean identity. It becomes 1. So I'm left with 1 plus cosine x all over sine x times 1 plus cosine x. And I had kids in 7th period to go, oh my gosh, these two will cancel. You're right. They match exactly and they cancel. Leaves me a 1 on the top. It's a placeholder, okay? So this is 1 over sine x, which is equal to cosecant x, and I do this more times than I want to admit. Cosecant x, hot dog, got what we want. And I'll give you a big smiley face with his tongue sticking out. Yay! Okay, got it done. This one's so easy, I'm going to let you do it. You can work on either side, but I highly recommend that you take the cotangent and turn it into sine and cosine. Okay? This one, I think the right side is more complicated. So now I'm going to tell you, this is no different than if you have a minus b all over c, and you turn that into a over c minus b over c, and you work it out like that. So watch what happens. I get cosecant is 1 over sine over secant minus secant over secant. Now, I didn't bother to change secant because secant over secant just becomes 1. Okay? So that means I'm left with this one with a minus 1 after it, so I got to keep, change, flip. So this is equal to 1 over sine divided by 1 over, well, what is secant? 1 over cosine. Okay? And then I still have this minus 1 hanging out from right here. Okay? So now keep, change, flip. 1 over sine times cosine over 1. Guys, what does this become? That becomes cotangent. Cotangent x, and that minus 1 is still hanging out. Holy mackerel. We did it! Yay! You know, I got one more. Let's do it. All right, definitely this side is the ugliest side on the left side. What I think I did was turn these into sines and cosines. So let's do it. 1 over cosine x minus sine x over cosine x times 1 over sine x plus 1. All right, these two match and I have a common denominator. So I can add these two. I get 1 minus sine x all over cosine x. Over here, they can't be added until I multiply top and bottom by sine over sine. Okay, so now I have, and I've got to multiply just the 1 by that. So what that leaves me is sine over sine. So I've got times 1 plus sine x all over sine x. Okay, now I'm going to multiply straight across the top, straight across the bottom. Now across the bottom's easy to see. Across the bottom, I get cosine x sine x. That's the easy piece. The hard one to see is that this piece on the top is no different than a minus b times a plus b, and this is the dots problem, difference of two squares. Okay, so what that looks like right here with my 1 and sine is 1 squared, which is 1, minus sine squared. And now sine squared x, 1 minus sine squared x is equal to cosine squared x. Cosine x, sine x, and we are so close to being done. Now just remember that cosine x squared, so cosine, that means cosine x times cosine x. This cancels with that. Cosine x squared is gone because I turned it into two cosines. So that's cosine x over sine x, which is cotangent x, and hot dog, we're done. Okay, all done.